Hi guys, welcome to mini lesson 3 on balancing hydrocarbon combustion reactions. We will say HC if it's a true hydrocarbon. I know we're going to try practice these in number 9, page 16, but I'm going to just walk through a couple of them with you. Incidentally, the true hydrocarbon combustions are the ones where you see there's a hydrocarbon and the rest of the equation or chemical equation is joining oxygen and forming CO2 and H2O, as you see happens with the first maybe 6 of them. Incidentally, after this, they are not hydrocarbon combustions like all of these are, because we see that it's some compound, an element, and forming 2 other compounds. So that would be considered an other, as is the case for H and I and J, which you can see a lot better on your notes than you can see here. Okay, we're going to assign the balancing here of maybe A, B, C, and F, A, B, C, and F when you're doing your balancing, but I'd like to practice D and E with you to show you how I walk through a hydrocarbon combustion balancing, because I did mention we do have to balance in the order that you see those elements. So always balance the C first, the H second, and the O last. If you look down at D, as I walk through this in our little mini lesson on hydrocarbon combustion balancing, you can see that if we're balancing our carbon first, I have 8 on the left side of my equation, so I must put 8 on the right side of my equation, and that looks good. In balancing the hydrogens, in this case, you don't see an OH on this side, so you can just leave it, the water, as an H2O, but we have 18 hydrogens here. Scooting to the right, that means I will have to put 9 hydrogens here, and to do that, I also will have to be careful in the fact that there's oxygen on 2 sides here on the right and only 1 side here on the left. So far, our hydrogens seem fine and our carbons seem fine, but oxygens will make things a little bit tricky. So that's why we leave them to last. So on the right side, we have oxygens in 2 places. So we're going to add those up first and then balance it by looking at the one spot where we can still put a coefficient on the left side. So my oxygens on the right side, 2 times 8 makes 16 over here. And then you notice you have to add 9 to that. And we get a very odd number of 25 oxygens on the right side over here, and that does make it tricky, because when we look over here, in order to make 25 oxygens here, it's got to be 2 times something. So that's why this is not that simple. What the rule is here is that you just put the entire 25 and you don't split it up and call it like 12.5. So because there's 25 oxygens on this side and we say 2 times 25 on this side, we do have to address that now this actually means 50. So you've doubled. And that is going to cause a problem with all of these on the other side. So the simple way to do this is by doubling all of the coefficients that you had put down on the right side. And what happens with that is you can see that it also 16 carbons means that you've got to double whatever you've got in all of the other 3 parts of the hydrocarbon combustion reaction in order to make it equal on both sides. So to go over that again, all I did was I first worked with the carbons, and we put 8 carbons to make them equal. We put, for 18, I put 2 times 9 will make 18 hydrogens. So I worked with my carbons first, my hydrogens second, and the oxygens being last. When we added up 16 oxygens over here and 9 oxygens over here and realized it was 25, I put the whole 25 on the left side, but realizing it's actually 2 times 25. So you're multiplying everything by 2. And that will make a balanced hydrocarbon combustion reaction. Let's walk through the next one. That's E. Give you one more practice demo, and that should be something you can watch and rewind or find a video on. But after this last demo, I think you can do the 4 assigned questions. For E, well, remember I'm starting with carbons. I see that there's 2 carbons on the left, so I put 2 carbons here, so our carbons are good. I see H's have to be balanced next. I see 2 hydrogens here, 2 hydrogens here, and they are fine. Oxygen is last, so adding this up, 2 times 2 means 4 oxygens, and over here I have 1 oxygen. That adds up to 5, and if I go over here looking at the spot where I can balance my oxygens, I put the whole 5 here, but that means there's 2 times 5, 10 oxygens. So because I've doubled my oxygens, I go and double everybody else, and that will make our formula balanced, and you can add it up and try it out. So we put a 2 for that one. This will be the 5. This will be 4 CO2. This will be 2 H2O. And that will be a balanced hydrocarbon combustion. Your assignment for this section will be A, B, C, and F. And you guys can give those a try and